Okay, hi everyone. This is part 2, and I'm going to show you how to use Microsoft Excel to create lines of best fit using charts and some other tools in Excel. So I have 2 examples I'm going to cover. This start file is posted on LMS. So if you're watching this video and you want to follow along and do the same steps as me, please download that file. It'll look exactly the same as this, and it'll even have the data here. So our first example I have is the same data from example 1 in the first part of the lesson. So I want to show you that this will output the exact same line, okay, and its associated equation as you saw when we did it by hand, okay? And the reason I show you that is I want to show you that what I gave you for those formulas is exactly what Excel is doing for you, okay? So to do this, we need to create a scatter plot. A scatter plot plots each of these data points as X and Y, okay, just like you saw in our example. So you can highlight your data and you can go to the Insert button. And under Charts, you'll see that you have 2 options that you might see immediately. This one here that has lines with points, you do not want to select that. This will graph each of your sets of data points as 2 separate lines. So if I hover over one of these, okay, and I click it, I'll click it just to show you. It's graphing each one of them as just 1, 2, 3, 4, 5. Okay, so just X is common. The X-axis is common to both sets of variables, but it's treating these as separate pieces of data. Okay, so line graphs don't look for 2 distinct inputs. Okay, so you do not want to select that option. When you highlight this data, go back to Insert. So I told you, don't use the line graph for this. What you want to do is go to the one that has just dots. Okay, that creates a scatter. You can call it a scatter plot or a scatter chart, and it plots these as X and Y. So it plots each of these as one data point. So 1 and 3 is one data point with X and Y coordinates. Okay, 2 and 6 is one point with X and Y coordinates. So I'm going to click here, and you have some options. You can select ones that don't show. Okay, they don't show the points. Some people like them because they look a little fancier, but we don't want that. We just want the raw data. So we're going to go to just the plot, where it just plots the points. Okay, so you can see it's plotting each one of our points from our previous example. So you select it. I'm going to move it up here just so it's sitting beside this data. And now, if we're clicked on the chart, we have the option up here that says Chart Tools. If I click on a cell or click anywhere else, you can see that the Chart Tools goes away. So when I click that, it's specific to this chart that I'm selecting. Okay? So if I click Design, you can do all the other features. We talked about that in our previous Excel, where you can change the colors to make it look all nice, or maybe you have a company color you want to use, and that's fine. What we're going to focus on here is, remember, you can add chart elements. Okay, so if I click on Add Chart Elements here on the left, I can add axes, okay, or titles for them, titles for the chart if there wasn't already one. But you can also add a trend line. Okay, so if I go all the way down here, you can see there's none here. I can select a linear trend line, okay, which is the same as our linear regression. So if I click that, it automatically does the calculation, okay, and puts the line of best fit. Now the problem with this is we don't actually know what that line is. Okay, what is the equation of it? How does it change? Okay, and that's easy to figure out. So if you remember from our last lesson, if you press Format up here under Chart Tools, you can click on this trend line, or you can click on any piece in this chart, but we're going to click on the trend line. Go back up here and click Format Selection. Now when we do that, we have values up here that we can change. So we can change what type of trend line it is. We can also set what we want the y-intercept to be. Now that's overriding it, so it doesn't become a true line of best fit, but you can override your intercept value. I'm not going to click that. But what I am going to click is to display the equation on the chart. So if I click this, here's our equation. Y equals 2x plus 1. Now remember, our solution that we calculated by hand was y equals 2x plus 1. The exact same value here, okay? So Microsoft Excel will find that line of best fit, and it finds it based on the type you pick. So remember, if I go back to options here, actually it shouldn't be under options, not under label. I need to click on the trend line, and under options, I can change the type of trend line. Okay, but in this case, a linear trend line I think fits the pattern best because it shows, all right, that as x increases, y increases as well. Okay? You can go back in here. You can click on, let's say, the fill button. I don't personally like that that's a dashed line, but some people do to kind of show that it's not part of the data. What it actually is a piece that we've added. I do like to change the color, so we could pick something like orange. We can also make it so that it's a solid line like this. Okay. So you can make some pieces. You can also move this to be anywhere else, anywhere you want, okay, this equation. Or you can edit it. If you remember in our previous example, you could change this, okay, to say y equals 2 times the temperature plus 1. Remember, when we did it as pressure as a function of temperature in lesson 4.5, okay? So you can edit that so it doesn't necessarily say y equals 2x plus 1, but by default, it will show it as y and x, okay? Y-axis being up and down, x-axis being left to right, okay? So that's our first example. Our second example has far more data points, but we're going to approach it the same way. Okay, so I'm going to exit this window on the right here, so we're starting from the same point. I'm going to highlight all of these data points here, go to Insert, and once again, remember, you're pressing the scatter plot. So I want the basic scatter plot, okay, with just raw data. So I'm going to select it. This one's not as easy to spot, right? So I can move this into a location here. And I once again can go up here. If I'm not already under chart tools, I can select design. And in this case, I can go to add chart element, go once again to trend line. And because we're doing linear regression, I will pick linear here. Now you see what it drew for a line, in my opinion, doesn't necessarily show the line of best fit, right? In general, this is increasing. But remember, the line of best fit, what it calculates is it calculates the difference between the y value of each point and its associated part on the trend line, and it's trying to minimize it. So what's happening is these values that are outliers, as they're called, that don't fit the general pattern, you see this value down here is really low, this one's a little low, and this one's quite high. They don't fit the general trend of the rest of these points, right, where they're kind of trending upward. So what I want to show you is what happens if I change those, okay? So if this data changes, your line of best fit will move, right, because it's trying to find that optimal value that's the smallest it can be, the difference between these y coordinates. So if I take these outlier points, the first one being this value of 60 here, let's say I change it to 30, or let's say 40. Okay? You can see that it kind of moved a little. Somewhat of a bad example because it also moved your grid lines. Now let's go once again let's go to this point here, 26. Again, it's a little bit low. Why don't we try and get it up here, maybe to about 28. Now you see the line of best fit moved upward just a little bit, and it's because that value changed. So it allowed it to shift that to be in the optimal location once again. Now, if this last piece once is another outlier, let's say that value was actually calculated incorrectly, and let's say it's closer to something like 30. Now you see that it's shifting up even more to show this kind of upward trend. Okay, so what you're seeing here is it's kind of a straight line. You know, we'll get into nonlinear regression in your second lesson as part of this. But it's just going to show you that that line changes depending on what you have for your data. So having a lot of scattered data, okay, data that's all over the place, is not good data to use for a line of best fit, specifically one that's linear like this. Okay, but what I can show you is, once again, if we click on, let's say, this line, I'm trying to click the line, see if I can get it clicked. I'll click Format, okay, and I'll click Format Selection up top here. I can change this. So once again, I can click Display Equation in the bottom right corner here, and it'll show it. You can see that this equation looks a little bit different, okay, 0.9 times x plus 10.8 approximately. And if you watch, let's change one of these values. I'll change this value, the last one, back to the value of 8 that it was. And you can see, look at how the slope changed from 0.9 to 0.6, okay? Drastic change, and the y-intercept changed by almost 3 points upward, all right? So it might have looked like a small change here, okay, undoing that, but it has dramatic consequences to what that line of best fit is. So it's important that you have good data when you're putting it in to do these lines of best fit. They're good to get overall trends, but they don't always work well in terms of telling you what that data is, right? This line here, look how far away it is from a lot of this data, right? It's trying to fit the line to minimize the difference between these. But you can see an instance like this where the values are all large. So this actually is not a reliable line of best fit. But maybe you could click this line and change it to something else. Logarithmic. See how the graph kind of changed. And the function now is a function of ln. These are called nonlinear regression, okay? Where it's the same thing. We still have a slope, which is 10.6, and a y-intercept. But our function here, instead of it just being x, like when we do linear, it's whatever function we're trying to use. So logarithmic uses the log or ln functions. Polynomial will use, x squared plus x, okay, like a quadratic. Exponential will use the e function that we talked about, so e to some exponent. Okay? Each of them use different functions, and that's what's known as nonlinear regression that we're going to talk about in our next lesson. Okay, so I'll click back to linear just so you can go back to this and press exit. Okay, so that's how to do basic trend lines using Microsoft Excel. Okay, so that's all I wanted to show you in this part of the lesson. We'll go back to this a little bit when we talk about nonlinear regression. Okay, so thanks everybody. If you have any questions, feel free to send me an email on, or we can do a Teams meeting if you'd like. If you want to do something specific in Microsoft Excel, you can share your screen with me. Okay, thanks everybody.